So far we've been working with very circuits where we have some kind of a power source, a battery, and then a single device that gets powered, and we've got wires connecting the battery, the two ends of the battery, to the two ends of this resistor in this case. But of course we can have more complex designs than that. You crack open your computer or your cell phone and look at the boards there, and there's lots and lots of little devices that are all connected in very complex ways. So the first way that we can make this more complex is to, say, add another resistor, add another component into this system. There are two ways that we can do that. So if we want another resistor in here, do something like this. Have two resistors that way. Or we could do something like this. And have resistors in that way. And so the diagrams obviously look a little different here, but these two circuits are classified differently as well. So this arrangement where we have two resistors right in a row with each other, we call that a series arrangement of resistors. So there's a series of resistors. There's one resistor, and then another resistor, and then another one, and they're all right in a line like that. And then here, we call that a parallel arrangement of resistors. So these ones are actually drawn so that they're parallel, so that makes it a little bit simpler. But it doesn't have to be like that. You know, I could redraw this and make it a little less obvious that those are parallel. So we could draw something like this now. And so that's still a parallel arrangement of resistors, even though these two aren't drawn parallel to each other anymore. So parallel doesn't necessarily mean that they're drawn that way. It's a question of how they're connected. So if you look over at the series one, you'll notice that our current would run through one resistor and then the other. So it runs through here. Our current goes that way, and then it runs through here. Our current goes through that resistor, and then back this direction. All in one big circle. That's what makes this one series. What makes this one parallel is that our current runs this direction, and then it splits into two paths, and some of our current runs down like this, and I'm going to call that I1, and some of our current runs this direction. I'll call that I2. Our current splits up into two different paths. It's like if we had a stream that splits into two smaller streams. So some of the water goes down one path and some of the water goes down another path. Well, the same thing happens here. Some of our current goes down one path, some of our current goes down the other path. So if we have a split in our currents, that's where we say it's a parallel arrangement of resistors. And then they come back together at this point, and we go back to having a total current of I. So I1 and I2, they have to add up to I. We can't have current just disappear there, just like we couldn't have water just disappear along the way. And really, that's not a great analogy because the water, some of it evaporates, some of it splashes out onto the sides of the river or absorbs into the bed of the river. So really, this is a little bit different from water in that regard. We can't have that current splashing out of our circuit. We have to have all of our current conserved because these are just charges. We can't have our charges randomly appearing or disappearing here. They have to be conserved. So this is a parallel circuit. This is a series circuit. The other thing you can watch for here is whether these two resistors are connected at both ends. So this resistor has one end over here and one end over here. This one has an end here and an end here, and there's nothing but wires connecting these ends and nothing but wires connecting these ends. So we say that those two are connected, but connected on both ends, and that's what makes it a parallel circuit. These ones got an end there, and one here, and there's only a connection between one side of each resistor. So that current has to go through both of them. It doesn't get split up. They're connected just on one end. So that's a series arrangement of resistors. Here the current gets split up. Our resistors are both connected to each other on both ends. That's a parallel arrangement for resistors. We could go more complex than this. Let's say we have a circuit that looks like this. So which is this? Is this series or is this parallel? Well, it turns out that this is both. It has parts of it that are series and parts of it that are parallel. So we have some current that comes out this direction. It goes through this resistor. And then if we think of these as a group, it has to pass through that group as well. So this end and this end of the resistor, only one end of the resistor is connected to this group of resistors. So this section going from this resistor to this group, that's in series. But here we have our current split up into two paths. And so this section is parallel. So we would say that these two resistors, and we'll give those names, R1, R2, and R3. We'd say R1 and R2 are in parallel, or they're connected in parallel. R1 and R2 are parallel, connected in parallel. And then R3 and the R1 plus R2 group, that's in series. So if we combined these or thought of it as just one big group, that group is in series with R3. But R1 and R2 individually are in parallel with each other. And of course we can get more complex with this as we add more and more resistors. But being able to recognize when it's series and when it's parallel, that's the first step in solving these more complex problems.